cauliflower as the brain, and then they put Jello in it or something, and then make you feel it or something. So, okay, so we're gonna kind of get rid of this.
Same as the brain. The brain.
Yeah, I know you mean.
Yeah, well,
Yep.
yeah, some of those fixatives are a
It's
little.
like way worse than
Okay, folks, so
Weird, yeah.
whenever you have a specimen, you do as much as you can without cutting into it first. I mean, that's what doctors do for when you go. They try to assess as much externally, as possible, so that it's as least invasive as possible. And that's why you learn body regions, you learn your anatomy of where things are, so that even with palpation, you can discern a lot. And of course now with MRI, and there's so much technology to be able to look in the interior. But so what we have here is, of course, a vacuum-packed cow's eye, and I'm going to kind of pass this around, and of course it's cloudy now because of the fixative, the chemicals called fixatives, chemicals that perfuse or are infused into cells, keep the cytoplasm from rotting. Yeah, that's what fixatives are. They fix the tissue so that the tissue's there, but it's no longer biologically active, and the chemical additive is one that doesn't promote bacterial growth, therefore no decay, ideally. So what's this area right here? Anyone can say it. It's discolored now. It should be clear, but that would be the
Sclera.
No,
the cornea.
Cornea. Sorry.
The cornea. I know. Let's just all. It's Monday morning, so but come on, we got to get with the bone. So the cornea is continuous with the white, which. Why can't we see much of the white? I'm going to tell you why, folks, because there's the four rectus muscles, the superior rectus, the inferior rectus, superior rectus, inferior rectus, down below, lateral rectus, and medial rectus muscles. While you see a big gap between their insertion onto the oculus here, and you think, oh, there's just little strips, they truly all abut right up to each other, so that on a true specimen, including humans, you're seeing the tendon there, but they insert here and here and here. So truly, you don't see much of the sclera because it's masked by the. And do we have parts of the rectus muscles? Absolutely. Look at our posterior tissue. We have just tons of the muscle action here. And folks, it's skeletal muscle. And remember, this muscle was metamerically derived. In other words, it's not from branchial arches. Okay, so it's considered its motor is not special visceral. It's special somatic. It's just general somatic efferent in terms of its motor. And that's what cranial nerve 3 is. Even though it's a cranial nerve, it's still just the functional category of general, because this skeletal muscle of the orbit and the tongue, otherwise all other head and neck muscle is derived branchiomerically from those branchial arches and have to have their own cranial nerve distribute through them. So anyway, I digress.
What did you call that black part again?
Well, it's not black.
The clear stuff like on this. It's
the cornea. See, if I kind of push the aqueous humor up a little bit. Well, this is compressed, so it's wrinkly, but it should be perfectly round, folks. That's the whole idea.
So it's the clear, glassy part over the color.
There's the cornea right there. Everybody should know where the cornea is, and it's been discolored in this specimen because of the fixative. A chemical interaction took place and made it kind of cloudy. But the idea is there's the cornea. And the sclera we can't see much of because it's overlain by the skeletal muscle. But if I go to the back, what is this structure here, folks, sticking out?
Optic nerve.
Thank you. Optic nerve. Now, because we have no bony landmarks to go by, impossible to tell right or left eye. Yeah, impossible. Because we'd have to have some relative. But what we do know is if it's a right eye, then this optic nerve kind of is directed towards the left, and if it's a left eye, then that optic nerve would be directed towards the right. Everybody gets that. The optic nerve comes off the retina medially, and we can see that in a skull. Where do you look for that optic foramen? Way medial. Yeah, very good. So everybody's clear on that. Well, so what we're going to do, I'm going to first, and The cornea and the sclera are a continuous part of what structure of the eyeball, folks? I hope you'd say the outer fibrous tunic. Yeah. Now, you would. Does everybody know that the cornea and the sclera are made of exactly the same proteins? It's just that in the cornea, the proteins lay all in the same direction so that light passes through and shows clear. So what happens in the sclera? Why white? The proteins, that every layer is 90 degrees, and therefore it blocks the light or refracts it, it bends it in a different way, so you see it as white. It's exactly the same histologic tissue, however. It's just the arrangement. That's where molecular, arrangement, structure determines, well, both function, but they both function to maintain the integrity of the oculus and really maintain its shape, because they are very dense tissue. So what I'm going to do is I'm going to cut around the cornea, and we didn't get this far, but
Can we move the model?
oh yes, absolutely. But I hope you kind of did your reading. We know that there's an anterior chamber and a posterior, actually it's called the anterior cavity and the posterior cavity. Although the posterior cavity is called the vitreous cavity, so okay, a little bit of difference. But there's an anterior and a posterior cavity. And the anterior cavity actually has two subparts to it. It has the part in front of the iris but behind the cornea, and it has the part behind the iris but in front of the lens. So you can see how dense this is. I had to really work hard to, and I'm just going to clip around the margin of the cornea. And who can describe, can you give me the anatomical name of the margin I'm clipping around, folks? It's called the corneal scleral junction. Good name for it, right?
Yeah, it makes sense actually.
The corneal scleral junction. And what structure do you know lies here? Which you can't see because it's not been injected. But anybody?
The iris?
No, what was that little circle we pointed to on our corneal scleral junction when I did structure A, when we outlined, do I need to get that? Not the pupil, the canal of Schlemm, aka the corneal scleral venous sinus. Okay, now, so the cornea, which should have been perfectly clear, has been removed now, and what you're seeing right now is, of course, this dark structure called the iris. Okay, the iris is part of the middle vascular tunic. Okay, and it's colored. And then cows, the color of cow's eyes is always brown. They produce a lot, unless they're albino, then they don't produce melanin. But the iris, folks, is, and this whole thing is the iris. This whole thing, and of course the hole in the middle of the iris is called the pupil. Pupil. Okay, folks, there's a term for people who are born without an iris. It's called aniridia.
Is that what
Iridia
albino is?
No, albinos have an iris, it just has no color in it. If you've ever seen somebody who was born, and it's a fairly
They're kind of
high
reddish, though.
No, you go right up to them and you wonder, they have no colored part of that. All they have is the black pupil. So you go up to them and you think, I've had two students. No, you can't. No, you can't. It's just dark. But you know how most of us have the black pupil is small, and then you see the color, whether it's dark brown or blue or whatever color your iris is. But people who are aniridic, who don't have an iris, and there's a fairly high incidence of it. Of course, they have to really be careful when they go out in the sun because they have no way to close down the aperture that lets the light in. That's the whole point of the iris, folks, is to close down the area in which incident light rays can gain access to the retina. So, okay, so there you're seeing the iris. Now, okay. So what I'm going to do now is I'm going to hedge my bets, and I should remove some of the skeletal muscle, but I'm not going to just because of the thing. So I'm going to kind of try to make a transverse section, and in this case I'm just going to cut through. And now, you said, well, what the fluid in the anterior chamber, which we hadn't talked about yet, is called aqueous humor, folks. It's just very watery fluid. It's called humor is an old-fashioned word for a fluid in the body. And aqueous humor is what fills the small anterior chamber. The posterior chamber has what's called vitreous humor in it, which is a very gelatinous substance. So I'm going to try not to destroy the, I'm going to kind of try to do a transverse section here, which is, I hope I don't make anyone sick.
Oh, no, you don't have to say.
Oh, okay, very good. Actually, I'm going to go get the brain knife. Just hold away.
Just gotta get the brain knife.